Okay, for 38, they give us a table. Again, before you start doing any work when they give tables, understand what the table is, right? So it's a table of jumps on a trampoline. So on the first jump, this person got to a height of half a foot. On the second jump, they got up to 0.9 feet. On the third jump, 1.6, right? So the more times you jump, the higher and higher you go. Clearly up to a limit, I'm sure, but okay. So question A says make a graph of the data. So here's A. So a graph of the data, right? So the X is going to be the jump number, right? Jump number. And the Y is going to be the height, and I should specify in feet, right? Feet. And we can go, I don't know, 1, 2, 3, 4, 5, 6, 7, right? Okay, 1, 2. And then for jump number, right? 1, 2, 3, 4, 5. That's all I have. 1, 2, 3, 4, 5. And I'm just going to graph these. So at jump 1, I'm half a foot. At jump 2, I'm almost 1 foot, right? And at 3, I'm 1.6. So that's a little more than 1.5. 4, I'm almost 3, right? Almost 3. And 5, I'm 5.2. 1, 2, 3, 4, 5.2, right? And on graph paper, it would look nicer. Now, what you can see is that this is a curve, right? It's not a linear graph. Okay. Also, what you can see is I am not going to connect the points. Why am I not going to connect the points? I'm not going to connect the points because there's no, it's not a continual graph, meaning at 1.5 jumps, right, right between here, at 1.5 jumps, I'm not halfway between 0.5 and 0.9 as my height because I don't stay at a height and keep getting higher and higher. I go down and up and down and up and down and up. So this is not continual. It just means at the end of jump 2, I'm at 0.9. At the end of jump 3, I'm 1.6. But it doesn't mean at 2.5, I'm at 1 foot. No, I'm actually might be touching the trampoline at that point and be 0 height. So this is a discrete graph. I should also include a title, maybe trampoline jumping, right? There's my title. Okay, so that's A. For B, it says fully describe the graph. Okay, I would say it's a curve, right? It goes up, right? I would also say it's discrete, right? It means it's not continuous, meaning I'm not going to connect the points. You could say as X increases, Y increases, or better yet, I would say as jump number increases, height increases, but something along those lines. Okay, so it says for C, it says if this pattern continues, right, what are reasonable maximum and minimum for this graph? Okay, the minimum is easy, right? Minimum is 0, right? Because you can only get down as low as as touching the trampoline. We could argue that the trampoline goes kind of negative, but it really doesn't. Okay, now the problem is the maximum, right? This is tricky because theoretically, according to this graph, there's no maximum value, right? Because you keep jumping, you keep getting higher, right? However, we would probably have to say that that's not true. Otherwise, this person could jump into space. So I don't know. You could pick a reasonable number. I don't know what a reasonable number, maybe 10 feet, right? Maybe 15 feet, maybe 8 feet, right? Somewhere in that range, however high you think a person can jump on a trampoline. Okay, and then for D, it says, which family of functions could model this data? And this is clearly not linear. It is exponential, right? Exponential. Because exponential look like this, right? They look like this, and that's exactly what this looks like, right?